Hello, I'm Dave Slopsma from Dimensional Consulting. Today I'm going to talk about the net hole and slot, otherwise known as the dot and slot. Why do we do it, and how do we do it? Why we do it is because we want to very accurately locate our part relative to another part, in spite of the fact that we know there's going to be location tolerance between our features on our part, between our hole and our slot, and between the bolts or the studs or the pins that go through these from the adjoining part. But this configuration allows us, in spite of the tolerances we have, to have a very tight, accurate fit to our adjoining part. The reason is because our hole is going to be just slightly bigger than whatever goes through it, and it is going to locate our part relative to our adjoining part, both in this direction and in this direction. Our slot then is going to control the rotation, this rotation, between our parts. And they will do that in spite of the fact that the slot and hole can move relative to each other just from tolerance, and whatever goes through the slot and the hole can also move relative to each other. But that movement will be taken up by the adjoining pin or bolt or stud being able to move in this direction without interfering with the accuracy of our fit. That helps us get our accurate location that we need. So, how do we do it? And this is equally important. In order for all of this to work, the axis of the slot has to be in line with the center of our hole. I've seen it done where people put the axis of the slot in this direction or on some other angle, and that defeats the whole purpose. The axis of the slot must be oriented like this with the hole. And then how do we tolerance it? We have our three datum system. First of all, we have a primary datum. We've designated the mating surface to our joining part as datum feature A, our primary datum. And then for tolerancing our net hole, this is the center of the universe. It's not located to anything else. Everything else is located to it. It is held perpendicular to our primary datum A. Then the width of our slot is located to A and B. It's held perpendicular to A and located relative to B. And when I say it's located to B, it pretty much just holds it in line with B, because in this direction it's still free to move. But it's kept in line with B in order to take care of our degrees of freedom that we want to constrain. Then the slot in this direction has its own tolerance of position, and it's located to A, B, and C, because between A, B, and the width of the slot, we've constrained all 6 degrees of freedom, and now everything else, including the length of the slot, can be located to A and B and C. And if we have some other feature that we want to locate, we can locate it relative to A, primary, B, secondary, and C, tertiary. So everything now is fully constrained, and we have a very accurate location between this part and our adjoining part, in spite of the tolerances that are inevitable in this part and in our adjoining part. So that's the dot and slot, the net hole and slot. This is why we use it. Please use it this way and you'll have a very good design. That's my tip for today. Please visit my website at dimensionalconsulting.com, and thank you for your time.